Okay, we're looking at proportional reasoning, and the method we're going to use are some diagrams and concrete materials. The overall expectation is to solve problems involving proportional reasoning, and the specific expectation, solve for the unknown value in a proportion using a variety of methods, in this case, concrete materials. So we have our question here. We'll read through it once, and the second time through we'll highlight what's important. So Adriana works at a veterinarian's office. She needs to give a dose of medicine to a 22-kilogram dog. The recommended dosage for a dog that weighs 12 kilograms is 30 milliliters. Determine the dosage Adriana should give to the 22-kilogram dog if the rate remains the same. Show your work. Okay, let's highlight. Adriana works at a veterinarian's office, doesn't have too much important information for us. It's great, we know where she works, but let's look at some numbers and information we'll need to use. She needs to give a dose of medicine to a 22-kilogram dog. That's important, the weight of the dog. The recommended dosage for a dog that weighs 12 kilograms is 30 milliliters. That's important. That gives us a recommended dosage. They want us to determine the dosage, so that's the question asked. Determine the dosage Adriana should give to the 20-kilogram dog if the rate remains the same. So the rate is the same. Okay. Show your work. Okay. So we're going to make a type of list here. We have our category of kilograms, all right, and we have our category of milliliters. And we know that a 12-kilogram dog, right, that's this part here, 12 kilos, that dog would get a dosage of 30 milliliters. And we're going to be using the same rate for our type of dog. So let's, and I've already kind of brought it out here, let's break this down into almost a unit rate. I think that will help us out here. Since our independent variable is the weight of the dog, it's going to be per kilogram. So we're talking about a rate, we're looking at milliliters per kilogram, okay? And the per means the value of 1. So let's bring kilograms down to 1, okay? And in order to do that, we can divide by the value of 12. There's other ways we could do it. We can multiply by 1 over 12, but this is probably much simpler. And since we divided kilograms by 12, we're going to divide milliliters by 12, and that'll give us our rate. Okay, this will help us set up a ratio for our concrete materials. Okay, because we kind of want this to be as small as possible, and I've already actually divided this in my calculator. If you look, 30 divided by 12 is 2.5. So for every 1 kilogram the dog weighs, it gets 2.5 milliliters of medication. So I've kind of already built some of the info here, but let's use a star for our ratio for the dog. 1 kilogram is equal to a star, okay? So we're going to say this equals 1 kilo. While on the other hand, we have our 2.5 medication. Maybe it's a natural medication, okay? So it's flowers, is equal to 2.5 milliliters, okay? And this is the idea that this is 1, this is 1, and this is 0.5. So together it's 2.5. So we're going to set up that relationship every time. So the information we had, okay, was under kilograms, and we knew that the dog was a 22-kilogram dog. So we need quite a few stars here, okay? So we're going to kind of start duplicating. And I'll show you a fast way to duplicate, but we'll start off simple, okay? I'm going to start off by just cloning this. So here's another one. So now we're at the value of 2. And every time we do that, I'm going to need to clone these guys, right? We have another setup here. So here's another 2.5. So at this point, 2.5 plus 2.5. Here we're at our 2 kilos, right? We have 2 stars at this point. When we have 1, 2, 3, 4, and then these two together make another one, 5. So we're at 5 milliliters, okay? Now I'm not going to add the whole way through because it's going to take quite a long time. Let's get another star, okay? That gives us a 3. Okay, at 3 we know again we need a clone. We need another pairing of those, okay? So this is only at 3. So another quick way we could kind of do this is once I get 3, I know for every 3 stars, okay, this is the same type of ratio. Think of it like a fraction. Remember the ratio we had originally built was 1 to 2.5. With that being in mind, I now have 3 stars. So if I have 3 stars, that's the same as multiplying 2.5 times 3. That gives us 1, 4, 5, 6, 7.5. Okay, so for argument's sake, what I'm going to do is I'm going to clone 3 at a time. Clone. And now I'm up to 6. So I've really jumped up there very quickly. And that same idea. Put that other guy in there. Clone. I add another, I guess I should kind of do it over here. I've added another 7.5. So we're building up very quickly here, as you can see. It's going to become hard to count after a while. So let's build this page here. 1, 2, 3, 4, 5, 6. So now we're at the value of 6. I can then double my 6 again and continue this all the way through. I'm going to pause and get to the very end for us so you can see what the final result is. But the idea is every time we build 1 star, we got to build 2.5 of these flowers here. Okay, so let's see what our final result would be. So as we can see, our goal here is to finally increase our kilograms to the number 22. And what will that give us in milliliters? Well, I completed it over here on the other side, and we've counted it out. And you can quickly take a look if you want. You can always pause this to count. But there are 22 kilograms, or 22 stars in this relationship. And when there are 22 stars, when we add up all the flowers, including all of those half flowers, we get 55 milliliters. So it turns out, for a 22 kilogram dog, we need 55 milliliters of medication. If you'd like to see other methods for solving this, check out our other playlists on proportional reasoning.